So the subject is how to find the trigonometric functions, sine, cosine, tangent, etc., of any angle in the plane. And before we get there, what we're going to have to do is we're going to define and redefine a couple of extra terms that we've developed that we're going to need here. One of them, of course, one of the things that we definitely have to know is about our coterminal angles. So to remind you, a coterminal angle is said to be two angles that are coterminal if they have the same terminal side when drawn in standard position. So we can see a couple of examples down here below. We'll go through that. There's also something called a reference angle. Okay. Now my coterminal angle, I'm just going to go ahead and use the symbol theta to represent it. And for my reference angle, a reference angle is called the positive acute angle measured from the nearest horizontal position. We give the symbol theta prime as the reference angle. All right, so as an example, we're told to find a coterminal angle at theta equals negative 230 degrees, such that the angle is between 0 and 360 degrees, and then we're going to find the reference angle theta prime based on that. So what is our coterminal angle? Well, the easiest way to do it is, of course, at least in this case, is let's take negative 230 degrees and add 360 degrees, one full rotation, to give us 130 degrees. 130 degrees is going to be our angle theta between 0 and 360 degrees that we need. And the reason we need that, of course, is that we know that this is an angle that we can show is in quadrant 2. It's between 90 and 180 degrees, so that's good to go. All right, so 130 degrees, you see this illustrated above over here. Now what do I do about a reference angle? Well, because I'm in quadrant 2, the nearest horizontal position in quadrant 2 to 130 degrees is 180 degrees. So here's what I do. I'm going to take 180 degrees and I'm going to subtract theta to get my reference angle theta prime. So in this case, 180 degrees minus 130 degrees is equal to 50 degrees. And so 50 degrees is a positive acute angle measured from the nearest horizontal position, right, measured from the x-axis, that falls closest, right? So the 50 degree, that's our positive acute angle. That's what we want. Now, what happens if it's in one of the other quadrants? Well, let's say we're in the third quadrant. Well, in quadrant 3, the way that it works is that we would take our angle theta and subtract 180 this time. Remember, our goal is to get a positive acute angle between 0 and a positive acute angle, right? So we have theta, which is greater than 180, minus 180. In the fourth quadrant, sort of a similar situation to the second quadrant, except that our closest horizontal position there is 360 degrees. So if I want to find my quadrant 4 reference angle, the way I'm going to do it is I'm going to take 360 degrees and subtract theta, and that's going to give me my reference angle there. Okay, we can have a similar situation right over here in example 2, except in radians this time. So in radians, we're told find a coterminal angle to negative 4 pi over 3, such that the angle is between 0 and 2 pi. Well, again, we've done this. We're going to take negative 4 pi over 3. We're going to add 2 pi. And 2 pi, we know, being 6 pi over 3, gives us 2 pi over 3 as the coterminal positive angle between 0 and 2 pi. So that's what we want. We know that this is in quadrant 2. Very similar situation to the one we just talked about at left, only in radians. Well, what do we do here? Well, in quadrant 2, the nearest horizontal position in radians is pi. So what we're going to do in the second quadrant is that we're going to take pi minus theta to get our reference angle. So our reference angle in this case, theta prime, is going to be equal to pi minus 2 pi over 3. It's the larger minus the smaller to make sure we end up with a positive. And of course, that gives us pi over 3, and that is considered our reference angle. Okay. And in similar ways, right here, if I had an angle that terminated in the third quadrant, I would take my angle theta minus pi to get my reference angle. And if I'm in the fourth quadrant, I'm going to take my angle from 2 pi this time. So 2 pi minus theta is going to give me theta prime over here. So depending on which quadrant we're in, we can tell what that coterminal and reference angle has to be. Okay, we're going to use this here shortly.